Welcome to our talk today. We'll be talking about cross-platform plus PC handheld development with Unity 6. I am Abdullah Hamid. I am a senior product manager of Microsoft platforms at Unity. And today I'm accompanied by John Martin, who's an engineer at Xbox ATG. Today we'll be talking about Unity 6, Unity 6's platform support, and some new workflows and features that we have in Unity 6. And then we're going to show you how to get started with developing for Xbox on PC handhelds. And then we'll show you a demo that Microsoft has created to help you on your journey to develop for PC handhelds using Unity. So who's this session for? It's for mostly indie developers, mostly focused on PC and console development. You're either an existing or a former Unity developer, and you're a cross-platform developer, as you should be. And you have upgraded or thinking about upgrading to Unity 6. So let's talk Unity 6. Unity 6 is our most stable and performant Unity we have ever built. At Unity, we know you want to be free to choose the platforms you want to publish to and deploy your games to, because you alone know where your audience are and where to best publish your games. Unity supports over 20 plus platforms, and most importantly for this talk, we support Windows. We continue to expand and invest in simplifying cross-platform development. We recently released build profiles and the platform browser. The reception and feedback so far have been great and fantastic. And if you have used the platform browser or build profiles, show of hands. Okay, a couple of people. So that's great. You can now create different build profiles in Unity. For example, if you wanted to create a Windows build profile for when you approach media. You want to have specific scenes, you want to have specific settings, override different graphic settings. You can do that now and create a specific profile for media, for example, a media build, or create another one for a vertical slice that you're going to share with a publisher or something like that. You can now create multiple profiles for the same platform as well. So you can create multiple Windows profiles, multiple Android profiles, and whatnot for different purposes and override those settings. And when you're creating a new profile, you will be shown a platform browser will help you with suggesting packages or different settings they need to adjust so that it can get up and running with that platform as quick as possible. It's really a neat feature, especially if you're just starting development and you're trying to approach either media or trying to get a publisher deal or something like that where you need to create a vertical slice. You can come back and forth between different profiles, so you don't need to redo all the settings that you've done before. You can add different scenes to different profiles. I really like it. And one of the features that I really got excited about recently was multiplayer play mode, where you can create multiple instances of your player window, so you can test your multiplayer games with the same instance of the editor right there. You can have each window have their own inspector and different features to it. You can have your own console there for each instance of the player window. And this way, you can test your multiplayer games right there in the editor without leaving the editor. In addition to that, there is the Multiplayer Center and widget where it will recommend, it will ask you for the type of game that you want to build. For example, first-person shooter, how many players per session you want in that game. And it will suggest to you packages, different services that Unity has to offer, so you can get up and running with prototyping your multiplayer game as quick as possible. You can choose to host your server, hosted games with Unity Multiplay, where you can get features like cheat prevention, Or you can have client-hosted games with distributed authority using the distributed authority for netcode package that we have at Unity. Many of your favorite games are already made with Unity. I'm a fan of Dave the Diver myself. I've been playing it on my RG Ally. It's great for handhelds. I really enjoy it. And here at Unity, we keep ourselves accountable as well. We eat our own dog food. We have a new process that we call production verification, where we partner with game developers and publishers that operate on a massive scale. And we make sure, in some instances, we actually co-develop the games with them. For example, recently we have partnered with a developer to create survival kits, where we made sure that whatever we're developing is actually usable by developers. Many of the local Seattle games that you might see downstairs or at SIX, which is Seattle Indie Expo, or maybe at PAX, are made with Unity 6. Don't take our word for it that Unity 6 is awesome. Go ask them yourselves. Go check out their games, play it. They're pretty cool. So let's talk about PC handhelds. Microsoft partnered with ASUS, and they're releasing 2 devices in October. One of them is the Ally, or the Xbox Ally, which has a Ryzen Z2A processor. And then there is the high-performance model, which is the Ally X, which has a Ryzen AI Z2 Extreme. These devices are really cool, and Microsoft will be talking more about them at a later talk today. I think at 4:30 or something like that. But what? 3:45. You should go check it out. They're going to talk more about the specs of these devices and how exciting they are. But if you're a Unity developer, how do you target these PC handhelds? Well, luckily, these PCs are just PCs. So it's to target them, especially if you want to target Xbox on PC, it's the same way you target the Microsoft Store on PC. You use the GDK for PC, which is publicly available at GitHub. And Unity already partnered with Microsoft and unified the process of developing for Xbox on PC and the Xbox on consoles. And all you need is to get started is in Unity is to download the GDK API package and the GDK tools package from the package manager. It's available for everybody, even with a personal license. The first step always to target Xbox on PC is to join, is to get access to the Partner Center. And if you're an indie, the ID at Xbox program is where you want to get started. But even while you wait to get access to Partner Center, you can get started with development right away. You can install Unity, install the GDK on PC, which is available on GitHub, like I said, install the 2 packages, download the samples, the GDK samples that are available in the GDK API package. There's a bunch of samples there on how to save your game on Xbox, or leaderboards, user sign-ins, all of the Xbox network features are available for you to learn from these samples and how to access those. And also, Microsoft developed their own handheld sample for Unity that will help you in designing your game for handhelds. So there's 2 considerations that you need to have when targeting these devices. There's the Windows performance fit. If your game runs at 30 frames per second, you will get the Works Well badge on your game in the Microsoft Store. And if your game runs at 60 frames per second, you'll get the Works Great badge on your game. There's also handheld compatibility considerations that you need to have. Microsoft will give you different badges for how well your game runs on handheld. If you want your game to be compatible with handhelds, the game needs to default to controller input when the game first starts. It needs to have the accurate iconography. It needs to show the X button, A button, whatever. It needs to default to full screen mode as well. And the text in UI needs to be readable or recognizable from 12 inches away from the screen. These are small screens. People need to be able to see them. And text input needs to go through the on-screen keyboard. So how do you do this inside of Unity? So here are some tips that we came up with to get you started. First thing is to adjust the settings based on the hardware. You can detect what device you're running on by using the System Info API at Unity. The device type call here will return handheld if it's running on a PC handheld. So right away, you can know this is a PC handheld and do all the appropriate logic afterwards. I also found out that processor model will actually return to you the chipset that's being used. If it's the Z2A, which is the more, let's see, power constraint model, then you can adjust your settings that way. If it's the Z2 Extreme chipset, then you can adjust your settings automatically that way. You don't need to have players kind of mess around with settings, even though that's a lot of fun to mess around with PC gaming settings. But some players just want to play right away, especially when they're on the go. So you can detect those settings and adjust things, for example, like texture, detail, shadows, lighting, all these things. Maybe turn off ray tracing if the hardware doesn't support it. All of these different settings that you have in your game, graphic settings, you can adjust based on the processor that the games are running on. And anybody here using URP as their graphics backend? Great, good chunk of you. URP has a setting or a feature called STP, or Spatial Temporal Post-Processing. It's an upscaler, and it helps you kind of produce like anti-aliased images that are high quality with not a lot of graphics power, I should say. So it's going to be very efficient to use STP, and it will increase performance heavily in your handheld games. Also, these processor models are available on other handhelds, not just on this handheld. So you can take a look at all the handhelds that are available in the market right now, see what kind of processors they have, and adjust your graphic settings based on those processor models. The next thing is for input. We can use the input system to abstract all the input methods that are available within Windows. And if you detect that a device is a handheld, just default to controllers. And you can do that using the input system. Also, within the input system, there is a in-game hint sample that you can use to show the right iconography. It will help you on your journey to make sure that the iconographies are correct. As for UI, you can use UI Toolkit. You can use scale with screen size, or you can use constant physical size for text, and that will help the UI to be readable from 12-inch away from the screen. Also, Microsoft, as part of their sample, will show you how to call the on-screen keyboard whenever you enter a text field. Also, for the love of everything good, please profile on the device. I've seen so many developers who never profile on a device. Get a device, find a friend that has a device, something. Please use the profiler as well. Profile your CPU, your GPU, your memory usage. Make sure your game is as efficient as possible on these handhelds. These handhelds operate on battery, so you want to be as efficient as possible to respect gamers' battery power that they have left. Also, check the thermals. Make sure that your game is not causing the device to overheat. Nobody likes sweaty palms when they're playing games, so make sure your game is as optimal as possible on these hardware. All right, so Microsoft has created a sample that is in Unity that will help you optimize your game on those handhelds. It will show you how to determine if the game is a handheld, to calling the keyboard, the on-screen keyboard, detecting the DPI changes and scale the UI appropriately. All of these different scenarios are shown in the sample. Here's a QR code that will direct you to the GitHub repo where the sample is at. I will show this again one more time before we end. So if you didn't snag it now, you can snap it later. So I'll give it now to John. We're going to show you a demo of the sample.
Well, hello again. Thanks, Abdullah, for introducing. But once again, I'm John Martin. I work with Xbox ATG. I generally support in input services and anything Unity. So here I'll be demoing our Unity handheld sample. So this sample was primarily made to show all these different, all this information in Unity. We have a C++ version of this, but I also want to make a Unity version to show how we can achieve this in the Unity environment, of course. So one thing that we see off the bat is that we're actually not running on a handheld. For this presentation, we're only using a single device, which is this laptop. But as Abdullah said, handhelds run on the PC target. So the only difference that we're seeing in this sample, in this demo, is the fact that we're running on just different hardware, but it'll work exactly the same on handheld, except that it'll say that, yes, this is a handheld rather than, no, it's not. So we'll continue on with that. And I want to highlight a few main things in this. Abdullah already went over just a lot of the important information to consider, but I want to highlight the virtual keyboard, which is very important for handhelds, which generally won't have keyboards attached to them. So for text input, you can click on this and it'll bring up, you can see that there, virtual keyboard. I'm just going to say hello, very simple. So this is very important, obviously something you'd want to consider if your game will be running on handheld. Another thing I want to point out is text size. So text size is very important. I'm going to hit the minimum. Raise your hand if you can read it. That's what I thought. So the minimum required text size is 9 pixels of height at 720p. As you can see, that's very small. The minimum recommended, if you really want to go small, is 12 pixels at 720p. But as you can see, that's also pretty illegible. So even though we have these requirements and standards, it's very important for you to tailor your experience to what's best for your title. Maybe you have a little disclaimer or trademark in the bottom. Maybe this would be appropriate, but if players are trying to read an example tutorial, maybe this might not be the best. So for this sample, I hit an 18-point font, and this appears fine on the PC. This appears fine on ROG Xbox Ally. So again, what's really important is that you just custom tailor. Even though we do have minimums, it's up to you to really decide what would be best for your players. So other than that, the sample just shows a lot of information: network adapters, your DPI, screen size, so even input. So very useful information. Right now, this is just all on the screen. This doesn't necessarily show you how you get these. So now I'm going to back out the demo, and I'm actually going to open the Unity project to get into a bit more of how that works. Okay, so here we are on Unity project, exactly what you saw before. So because, again, this is a PC target, which will be thrown in the handheld, it's very easy just to test this natively. So we can just run it straight at the editor. It'll do its thing. All right, cool. And we see the same information. We can pop up a virtual keyboard. We can still not read the text, so on and so forth. So, okay, so what I really wanted to go over here was how we threw these together. So of course you'll need this information so you can make decisions on how you're going to optimize your game. And there's some main features. The system info class that Abdullah mentioned before contains most of the information that you're going to need. So what's the name of your device? What's the GPU information, screen size, all that. A lot of that can be obtained from the system info class. But not all of it at the moment. And the main way that we exposed this was we created a handheld helper DLL, that's what we call it. Essentially, this will expose features like the virtual keyboard, is this a Bluetooth device, so on and so forth. And at the moment, I'm going to jump into, I'm hoping you can read this. We call this hand helper DLL, and we call different methods. There is one called isDevice handheld, and at time of writing this sample, Unity didn't have handheld pushed into system info, but now it does. So the idea is this sample and this DLL are set up so that you can be enabled immediately. But as time goes on, more and more features, such as isDevice handheld, which is now within the Unity editor itself, will start to propagate and make its way through. So again, it's this way so that you can get started now, get all the info you needed, but expect updates in the future. And one last thing I wanted to go into was the UI. So going into the text, the reason why, the choice I made for the text in this case was to give it constant physical size. So if it's 9 inches tall on this giant screen, it'll also be 9 inches tall on a handheld. So that could be a choice you want to make. So let me hide this UI and I'll show you this UI. So I'm using here the canvas scaler, constant physical size, and that's how I'm able to achieve constant physical size. So right now it's going to get a little ugly for a moment. I'm going to switch to free aspect and everything's all jumbled. And as we see, as I change the screen size, the text size also won't change. There's obvious pros and cons to this. So again, this is up to your design, what you want to do here. But this, again, allows me to have constant physical size. So the other option, which I had for the background elements, I had the Windows logo and background and this little border here. I really didn't need it being constant size. In fact, it'd probably be preferable that it wasn't. So I used the scale with screen size option. So as I drag this, make it smaller, it scales with screen size. And I was able to hit a good balance. So if we put these two together, again, it's really jumbled in the editor, but we can see these scale accordingly. So these are very useful for Unity developers. I'm sure most of you probably recognize the scale of screen size, but using these two in conjunction, you can be able to get constant screen size, scale different UI elements as you need. So again, you have options. Tailor the best experience you can for your players, and that's essentially it. And that's what I really wanted to highlight in this demo. So thank you. There you go.
All right, let me switch back to our presentation. We're going to queue a little bit in a bit. All right, so where do you find help if you need help? Again, this is the QR code to the handheld sample that Microsoft has developed. And if you need more help, we got the documentation of the GDK API package that is available. Microsoft, the GDK documentation of Microsoft's website. Can also go to the Partner Center documentation as well. Unity discussions is a great place to post your Unity questions. And if you need professional help and you need to hire some folks from Unity to help you out, we got Unity Professional Services as well. And Microsoft also published a checklist for GDK games on Windows handhelds, where you can see what things are they going to check exactly when giving the handheld verified badge for your game. I'm going to try to share this as a PDF through Slice somehow, because these are actual links, so you can actually click on them and go to where you need to go to get some help. Again, just to wrap things up, Unity 6 supports 20+ platforms. There's a lot of cool workflows and features that we developed in Unity 6, like multiplayer mode, build profiles, platform browser, and a lot more. And we showed you how to get started with developing for Xbox on PC handhelds. And we showed you a demo of the handheld sample. Just a reminder that Unity 6.2 got released, and it's available now for everybody to use. And here's a QR code for a feedback form. Would really appreciate if we got feedback for this talk. It helps me become a better speaker, so please fill up that form, please. And now we're open for questions.
Any other Q&A like that?
Oh, that's the microphone?
Yeah, for Q&A.
Okay, so Yeah, people can walk up and just queue here. That will make it a lot easier to us to record the questions as well.
Let me know when you're ready.
Go for it.
Cool. So in specific response to the virtual keyboard that you have, does that support localization out of the box? And if it does, do you know which languages it supports?
I mean, it's the on-screen keyboard that Windows has. So like we're just calling a native
Cool.
Windows keyboard to show up.
So
And there is a controller mode now in it, and it will default to that in handhelds. So you can actually choose things on the keyboard with a controller instead of and touching it or something like that.
mostly it was for like language localization.
I mean, whatever Windows supports, it's going to show up.
Hey, thank you for the talk. In terms of haptics and doing cross-platform haptics, what would you recommend to take advantage of the handheld?
I mean, right now the handheld support Rumble doesn't support haptics yet, from my knowledge.
Okay.
And the input system does support Rumble, so we can just use the input system to access that.
Okay, correct. Thank you.
All right, since I got you here, what about IAP support, in-app purchasing support? I didn't see you cover that. In the current 5.0 release and the pre-release, don't seem to support or mention Microsoft.
Yeah. Right now, Unity's in-app purchase API and service does not support the GDK.
Right.
But we'll take that into consideration. That's definitely one of the things that we take a look at and try
Do
to
you know the backlog and where it is, or?
It's not anything I can share right now, but we're always prioritizing and looking into things that we can prioritize.
That might be helpful.
Sure. Thank you very much for the note. I'll take that to the engineers. Yeah.
Or you'd probably be.
This is a question I think probably more for you, John. How does the hardware respond to thermal events? For example, if game is running really hot, does the device do anything like throttle the CPU, throttle the GPU? Is there anything that the developer can do to respond to those events in a meaningful way?
Yeah, sure.
I haven't run into personally too much load testing in terms of thermal, but I'd imagine it'd be like a laptop where it'll start to throttle. But one thing that we really want to emphasize is being able to not work the machine too hard, to be able to optimize your game to ideally not push it into a high thermal area. Obviously, that's just the nature of it. Honestly, not the best person to answer that question, but I think it really just boils down to how hard is the machine running when it's trying to run your game.
Okay.
I hope that helps.
Great. Thank you.
My recommendation is to use the profiler. Please profile your game and check the thermal of the device while you're playing your game and play test it and make sure it doesn't overheat the device. In this way, you actually give a longer play time to play sessions to players who are playing your game, the less power it consumes. Maybe if you want to prioritize battery life, maybe have a setting in your game that says battery power, this is on battery power. You can detect if the device is on battery or plugged in and adjust your settings and quality settings based on that as well through the system info APIs.
Hello, I got another question for you. In terms of accessibility and screen reader support for the handheld, like we've got TalkBack for Android and VoiceOver for iOS. What would be sort of like the Microsoft equivalent for screen reader support?
Is that something you know about?
Not quite.
I'd say I'm not quite 100% plugged into accessibility features, but whatever is available in Windows will be available on the handheld.
Okay.
So whatever features you can get on the Windows PC will also be available on handheld.
Okay.
So I hope that helps.
Yeah, thank you.
Thank you very much for listening. I really appreciate it if you can fill out the feedback form.